Hi everyone! In this video we're going to go over an example where we are trying to find the maximum of a quadratic function, but there's a little extra work involved because the equation of the quadratic isn't given to us. We have to find that for ourselves. So we're going to focus a lot of our thinking about how we would go about setting up that quadratic equation. So this is kind of nice review for the functions, the modeling section. I think it's just called functions model, something like that, from earlier in the quarter. So specifically we'll end up with a quadratic, but there's similar types of problems. Okay, so here we're trying to build a rectangle. And what we know about the rectangle is that its bottom left corner is on the origin, so that can't move. And its top right corner just touches the curve y equals 8 minus 2x. So that's going to be a line with a slope of -2 and a y-intercept at 0, 8. So let's just say this is 8. And then x equals 4 will make y equals 0, so that's our x-intercept. Okay, so here's this line. So if the left-hand corner is at the origin, the right-hand corner definitely has to be somewhere to the right of that. So our right-hand corner is going to be somewhere along here. And it also says it's the top right corner. So our corner can't move past x equals 4 because then it would become a bottom corner. So somewhere in between x equals 0 and x equals 4, we get the right side of a rectangle, and it'll come up and it'll hit this curve, which is y equals 8 minus 2x. We are trying to decide where this bottom corner should be, so basically the x coordinate of that bottom corner, if we want to maximize the area of the rectangle. Okay, so for starters, there's always kind of a tug of war happening in these problems. You want to recognize that if your point can slide back and forth between the y-intercept and the x-intercept, what you're balancing out is that if you make it really close to the y-intercept, your rectangle gets really tall, which is going to be good for getting maximum area, but it also gets really skinny, which is bad for trying to get maximum area. And then if we go really close to our x-intercept, dead pin, we're going to get a really short but really wide rectangle. So that's what we're trying to balance out. If we get this thing taller versus if we get this thing wider, how do we get the most possible area involved? So generally it's somewhere kind of in the middle. So this is just an idea of what the rectangle might look like. First thing, you want to pick some of your variables out. You should end up with 2 variables, and you do sometimes have to pick them out yourself. But one of them should be very easy to pick out. Whatever it is you're trying to maximize or minimize gets a variable. So I'm trying to maximize the area. I'm going to call that A. Okay. And more specifically, whatever you're trying to maximize or minimize should be your output. It should be your y variable. The idea being when we go and we get a quadratic and we find its vertex, vertex gives you the maximum y value. So if you're trying to maximize something, you want it to be the y coordinate of your vertex, of your quadratic. The other variable can sometimes be a little bit trickier, but often the wording of the question should point you in the right direction, or asking yourself, what in this problem do I most directly control? What am I trying to decide? So here, the thing we control is where the bottom corner of the rectangle is, the bottom right-hand corner. So basically, it's this distance. So I know a lot of people would be able to pick out, we control the x coordinate of this corner. But again, it's really important that you visualize x coordinates correctly. X coordinates are horizontal distance from the y-axis. And in the same sense, y coordinates are vertical distances from the x-axis. So that's our x that we want to use. Labeling it in the picture counts as a definition. That's great. You don't have to also explain in words what that means. So I've got my 2 variables. I then just want to work my way towards how do I get an equation. Because this is an area of a rectangle, I know I'm going to need a length times a width. So as much or as little of this writing out as you need is great, but if you're stuck, just try and work yourself through more in English before you translate to symbols and variables. And then we want to replace both the length and the width of that rectangle by an x. So it doesn't matter which one we call length. Let's go ahead and just call length the horizontal one. That gets replaced by plain old x. That's really easy. The width will then be how tall the rectangle is. That's a little trickier, but we do have enough info. This, I would say, is often the hardest part for people. So a really good thing to ask yourself is, what is forcing this decision on me? So if I pick x equals 3, why can't I just pick any old height of my rectangle that I want? And the answer in this case is that the corner of your rectangle has to touch this line. So this line is forcing that decision on you. When you go to choose the height of the rectangle, it's determined entirely by this. More specifically, the width is exactly the y-coordinate of your point. And the y-coordinate of your point is always going to equal 8 minus 2 times the x-coordinate of your point. Straight from the equation, I get that information. That's exactly what that equation for that line says. My y-coordinate will always be 8 minus 2 times my x-coordinate. So the width of my rectangle, which is my y-coordinate, will always be 8 minus 2x. Okay, so there's my formula. I think that's generally the hardest part, but there is still a little bit of work to go. So if you're rusty with quadratics, it could get tricky. We're supposed to find the value of x, where we should put that bottom corner, so that the area is maximized, which basically means I'm being asked for the vertex. So I have a quadratic, and you always have your choices. You could say the x-coordinate of the vertex is negative b over 2a. This one is factored, so it's actually really easy to find the intercepts. So let's see, if x equals 0, we have an x-intercept, and also if x equals 4. Don't get mixed up with this picture. This is a picture of the rectangle. What I'm talking about is the area function. So this is a function where if I tell it where I put x, it will tell me the area of that rectangle. And it goes through 0, 0. So if x equals 0, we just get a straight line, no rectangle. And if x equals 4, we just get a straight horizontal line, no rectangle. And then if you multiply this out, it would be a negative 2x squared. So this opens down. So we're getting something like this. That one looks a little flat on the top. It's just really rough sketch, but that's my area function, and I'm looking for this point. So if I know my intercepts are at 0 and 4, this point has to have an x-coordinate of 2. So absolutely, you could distribute and do a negative b over 2a, and that would get you the same thing. But if your intercepts are easy to spot, the x-coordinate of your vertex is easy to find as well. So it looks like if I put the bottom right-hand corner at x equals 2, I will get the maximum possible area. So this is the answer to this question. I should point out that sometimes I might ask you what the maximum area is. If you were looking for that, you would just plug the 2 back in, and we would get 2 times 8 minus 4, 2 times 4, so it's 8 square units. I didn't give you units on here, but 8 square units is the maximum area. So you should be able to do either of those things. Tell me the x that gives you the maximum, or tell me the maximum. And you just want to make sure you go back and reread the question and make sure you're giving the right information. All right, thanks for watching.